kit is right there. And I can carry that anywhere in the world without any electrical cords, plug it in, and get my data. Or I could use it at any place in your plant. If you have a motor you need to monitor that is remote, or you have a door that's opening and closing that you need to monitor, or you want to measure the humidity anywhere in your dryer, you can use this equipment. This is an example of recording temperature as I'm extruding those small bars using my recording thermometer. And as I just run clay through, I build temperature. As I put my additive in, the temperature goes down. When I take my additive out, the temperature goes up again. This is the recording ammeter, and I can set it to record every 2 seconds, and at that, it will record for 24 hours continuously. There's also an option on this to record ambient temperature and humidity at the same time without any external hookups. On my lab mill, I coil the wires up so that I can get a stronger amperage reading. And the nice thing about these is they all download into Excel. So I can combine them, and now I see my amperage builds, and then it declines, and then it builds again with my temperature. We still need to know what the throughput rate is, though. So I use a pulse meter, and I'm recording every 10 seconds. So how many times does that reflective tape pass every 10 seconds? And this is the actual software for the data logger. I'll download that into Excel and overlay it. There's a little variation, but no big trends like we saw before. So now I can put all those together. And I see that at relatively constant rate, with no additive, I build amperage and temperature. With additive, it goes down. Take it out, it goes back up. And then the final thing is always water. And I don't have a meter for that. So I have to cut the bars and measure the water. And then I can plot that on the bottom. And then just making some graphs in Excel. For instance, I measured dry density and plotted it as a function of water, and I can see that there was a real change with the additive that corresponded to what I was measuring. Looking at pore water, there's a shift in pore water. Looking at plasticity coefficient, again, there's a shift. So there was a real physical change due to the deflocculation of the clay, and I was able to measure that, the indications of that, with the data loggers for temperature and amperage. Penetrometer, the clay got softer with the conditioner in it as well. Now, that was in my lab. I do exactly the same thing when I go into an actual brick plant. I use a bigger CTV. That's the only difference. Use the large clamp here to go up to 600 amps. This is the actual data logger, and those little holes right there are for ambient temperature and humidity. You don't need to put any other equipment in there for that, but I've plugged the CTV into the logger. So that's how it sits. You can put it in a dirty, dusty place. You don't need any extension cords. Cost $110. Really nice little tool. You can carry it in your pocket on the plane when you go to Brazil. Sneak it through customs. Monitoring the extrusion amperage. In an actual brick plant, we were running with additive. We took the additive out. We can record amperage jumping up. We can also see shutdowns here. So if you want to monitor your process and see if you're running smoothly or if you're having how many interruptions you have, most modern brick plants have this built in. But if you are visiting a site or you're not a modern brick plant, this might be useful to you. So I saw amperage change. We have to look at production rate. This is my LignoTech Pulse 101 data logger, and it's hooked into an external power source, a Monarch battery that is hooked into a light source, And I think I probably have those all pointed out. I don't even need the pointer. So what I've done is put a reflective tape on a 9-inch texturizing wheel here. Every revolution is 12 bricks. So I can get, as we were talking in the last talk or 2 talks back, tons per hour. I can get the actual production rate instantaneously. Sometimes I put it on the cutter, but the cutter just gives me 7 to 10 cuts per minute, and I'd like a more continuous record. Another option, you can put it on one of the rollers down below, and this gives you a lot of revolutions per minute. You just have to make sure that roller turns continuously as the belt goes over it. So in this case, I overlap them, and I see there's no change in production rate corresponding with that change in amperage. So it's most likely the additive that caused that. We want to look at recording temperature. Now that laser beam shows where the temperature is recording. That has nothing to do with the recording process. It's an infrared recorder. I generally set this up to take a reading every minute. And it will take 99 readings per channel. There's 8 recording channels. And it will download into Excel. We can see here that temperature increased and then declined again, just as it had in my lab mill. Okay. When we do these field tests, we take a sample of bricks every 10 minutes. We cut off a piece and we measure the moisture to ensure that none of those changes were due to moisture. Again, just like in the lab test. Okay, this is the bottom line. This is my inventory, my part list here, and this Hobo U2 U12 data logger, $119. Is just such a nice tool to use. You have to buy some software for it. The CTV is a little bit expensive. We're looking at LignoTech for the pulse or the RPM meter, and the infrared is an Extrusion. And I also threw in the Pelican case that I carry them all in. All goes in one kit, all about $1,200, and it's excellent tools. That was a very short talk. But I just wanted to let you know these things are out there, and if you want to monitor your air conditioning in your office, they're wonderful. You want to see what time your kids are coming home at night, you can do that too. You know, just a little imagination, you can do all sorts of things with these tools. So, tried to share with you and put you back on schedule a little bit.